So we've been talking about how to combine two or more functions using basic math operators, our addition, subtraction, multiplication, and division. Today we're going to start talking about how to combine functions using what we call a composition. So what we'd like to be able to do by the end of class, next time we meet, is to determine if a resulting function or to determine a resulting function from the composition of two functions, or in other words, to compose one function with another, and to determine the resulting domain of those composition of functions. So a composition of functions is basically when you plug one function into another function for its variable. So for example, if we had two functions, f of x and g of x, the composition would be one of two things. We could plug g of x into f of x, or we could go the other way and plug f of x into g of x. So essentially, we're substituting anywhere we see an x in the first function with the entire second function. We can write a composition of functions the way we see it here, or it can also be written the way we have it here. And it's just read f of g of x or g of f of x, g of f of x, either way. So what I'd like to do is kind of go through with you quickly in the video how to compose one function inside another and to determine the domains of those two. So this was not included on the original worksheet, so please make sure that you include it now. So to find the domains of a composition of function, you basically need the domain of each original function. So if we call them f of x and g of x, you would need to know what the domains are of those two functions. And then the domain of the composition is the intersection or the x values that overlap in both of the original functions. Okay, so if we take a look at our two functions, let's say we have f of x and g of x, like we have here, and I'm going to use colors to code this. This, if we were to graph it, is a line, and this is a parabola. Both of these domains are all real numbers. They extend forever and ever to the left and to the right. So their intersection of their domains, because they're exactly the same, is going to be all real numbers. If we write it in set notation, it looks like this. X is an element of all real numbers. Or if we write it in interval notation, it looks like this, from negative infinity to positive infinity. Okay, so here what I'm doing is I'm taking f of x and I'm plugging g of x into that. So what I'm going to do is I'm going to write f of x. So f of x is negative 2x plus 5, but instead of writing an x, I'm going to leave a big wide open parentheses, and in that I'm going to plug in my g of x. So you can see, so we took f of x, we replaced the x with a set of parentheses, and then inside that parentheses we substituted in g of x. So we put g of x into f of x. If you can simplify that from here, please do so, otherwise we'll do that in class together. The other way that we can compose two functions is to put g of x on the outside and substitute f of x into that. So we can do that by, again, rewriting g of x, which is x squared plus 3x, except replacing the x's with big sets of parentheses. So we have a parentheses squared plus 3 times parentheses, and then inside those parentheses, that's where we substitute in our f of x, which is the negative 2x plus 5. If you know how to simplify this from here, then you are good to go. You should do that. Otherwise, we are going to do that together in class. Again, the resulting domain would be all real numbers. The last thing I want to talk to you guys about together in this video is when we evaluate a composition of functions. So here, the only difference is that we are replacing the x with a 4, which means we're not going to have any variables in our answer. We're going to get a single number as an answer. So I like to do these kind of one at a time. So I'm taking 4 and I'm going to plug it into h. so that it looks like this. So I'm rewriting h of x, except I'm replacing all of the x's with a 4. And that's something that we're used to doing. We're used to plugging a number in for x and seeing what we get. So then we end up with negative 36. And then that number we're going to plug now into f of x. So then what we end up with is f of x is that square root of 2x minus 4. And I'm going to put my negative 36 into that. So then when I simplify that, I get the square root of negative 76, which is 2i times the square root of 19, if you remember that. I know that's all way too much math, but if you can at least get it to the square root of negative 76, then we're on good shape and we can review imaginary numbers later on in the